This is a pre-calculus. We're gonna discuss about rational function. First, what is the rational function is? So here is definition of rational function, guys. F of x is a fraction form. P of x over Q of x. That's what we call rational function. P of x is a polynomial function. Q of x is a polynomial function. But very importantly, denominator cannot be zero, guys. That's the we're gonna call rational function. Very important concept on the rational function is gonna be, guys, always looking for a domain. So domain is very important. How can find the domain? You're gonna find all the x value doesn't make denominator zero. So another way, you're gonna find the x value which make a denominator zero, that's exclude from the domain. Before we figure it out what is domain gonna be, we're gonna talking about example of a rational function. So rational function looks like this one, f of x, 1 of x is a polynomial, 1 is constant is also we say polynomial, okay? G of x denominator this one, polynomial degree 1, linear function, right? Degree 1 polynomial. This numerator degree 1 polynomial. Let's do one more, guys. H of x, let's say x cubed plus 1, x squared plus 2x minus 1. That's also a rational function. This is a degree 2 polynomial. This one is degree 3 polynomial. All this form of function we call rational function, okay? What's most important when you're talking about rational function is domain, guys. How gonna find the domain? We already talked about domain gonna be. So what you have to do, guys, here, what you have to do, denominate gonna be zero. We're gonna remove from the earlier number. So what is denominate? Denominate x. So x equals zero. That's gonna remove it. Another way you're gonna see the other way say x equals 0 is number line. So here is a 0, remove it. So remove x equals 0 is right here, the other side. So domain gonna be negative infinity and 0, 0 and infinity. That's the interval rotation. Or cell rotation, you're gonna write down x. You're gonna put all the x cannot be 0. Why? X equals 0 denominate 0. So that's why it's cannot be in the domain, guys. That's how to find the domain. Another thing is when you find the domain is what's the behavior f of x nearby the exclusive point, x equals 0 this time, okay? So let's check it with the table, guys. Look at this one. When you plug in the very close to the 0, guys, look at the 0 0.001, 0 0.1, 0 0.1. All this one is bigger than 0. Notation-wise, x gonna be close to the 0 from the right. That's your rotation coming from the right, guys. Approach from the right because all of these x value greater than 0. So when you plug in, so f 1 over 0, 0, 0, 1 gonna be 1000. 1 over 0, 0, 1 is 100. 1 over 0, 1 equal 10. 1 over 1 is 1. What happened? Look at this one. So when you x value getting close to 0, number is 1, 10, 100, and 1000. We're gonna rotation gonna be infinity, getting bigger. That's the rotation, guys, okay? The other way, so this one is all the less than 0. This number gonna be all the less than 0. So we're gonna another rotation is x approach 0 from the left. Okay, what happened then? Here is negative 1, negative 10, negative 100, negative 1000. This value gonna be number is bigger but sign is negative. Notation gonna be this one is negative infinity. So at the x equals 0, y value gonna be getting bigger. Y value gonna be getting smaller. That's the specific definition in the rational function. Let's do practice problem. Find the domain of rational function, guys. So you have to write the domain in an interval notation. So let's do g of x. G of x gonna be g of x, 1 of x plus 1. So which x will make a denominator 0? So we're gonna see, okay, denominator x plus 1 equals 0. So x equals negative 1. So draw the number line. Here is negative 1. Exclude negative 1. So you're going to have this one and this one. So interval notation, negative infinity, negative 1. Or union, negative 1 to infinity. That's the domain. Another way write this domain is a cell notation. You're going to write this way. X value, x cannot be negative 1. So that's the exclude from the Euler number, guys. Okay, let's go number 2. B bar h of x function. H of x function is 1 of x squared plus 1. Let's check the denominator. This one, x squared plus 1. So x squared plus 1 equals 0. Think for a moment. This one, can you find the x value? Someone tempt the x squared is negative 1. You cannot find any solution. This is complex number. So you cannot find any x value make x squared plus 1. So domain gonna be Euler number or negative infinity and positive infinity. So when you're talking about domain of rational function, always check the denominator, guys. Next is very important concept is vertical asymptote line. Vertical asymptote is very related of domain. So this one is behavior of function of f nearby the x value which make denominator 0, guys. So what is the vertical asymptote? The meaning is gonna be x equals c. That's the vertical line. Let's say this is a c value. That's the vertical line. X equals c. Look at the shape of graph. X approach to this direction or this direction. We talk about it. X is less than c, greater than c, coming to the c. Y values go up, keep increasing. Y value is going down, keep decreasing. We call this one, this line gonna be vertical asymptote line. This is very related to domain. Okay, guys, remember that. Okay. Another definition is a horizontal asymptote line. Horizontal asymptote line, horizontal line right there. This one name is y equal d. What happened? X is going to this direction. X is going to this direction. X going to the infinity. This graph is getting close to the line. Line is D. So fx is getting close to D. We call y equal D is horizontal asymptote line. X is getting bigger, y value is getting close to the value. Another way, x go to this direction, x go to negative infinity, opposite direction, function gonna be fx gonna be close to the. Also, this is horizontal asymptote line. So one of them is happen, this behavior, we're gonna say that's the horizontal asymptote line. Let's have the example and next slide, this one. I give the graph, guys, look at this, each graph, 3 rational function. Let's find vertical horizontal asymptote from the given graph. So first one, what is vertical asymptote? Vertical asymptote, see the line, vertical line right there. What's the behavior? X coming here to the right. That's going to be x coming to the 3, positive, y's go up. Fx going to be go up. Coming from the left, x approach the 3, negative. Coming to the left, y values go down. Fx going to go down. That's the negative infinity. Then what do you find it, guys? What do you find it? What is the vertical asymptote? You're going to say x equals 3. Vertical line, guys. Guys, remember that vertical line, we're going to talking about vertical asymptote. Horizontal asymptote going to be, horizontal asymptote this time. Horizontal asymptote gonna be x is going to this direction. What happened? This one closed where? This horizontal line, right? So this one is y equals 0. Let's go this direction. X going to this direction, x is negative infinity. Oh, this graph getting close this line. That's the y equals 0. That's you're going to find it. How about second one? Second one, can you see that? What is vertical asymptote, guys? Coming here, go down, coming from the left, go up. So you find this one, x equal 1, right? Now, x equal, let's say 0.1. That's the fair, right? So vertical asymptote gonna be x equals 0.1. Let's say that. It's not really clear. They didn't label the exactly number there. So we're gonna use that one. How about another one? Do you have see another one, guys? Can you see another one right here? Okay, right there. X approach to negative 2 to the right, go up. X approach to negative 2 to the left, go down. So X gonna be negative 3. That's another one. Okay, what is a horizontal asymptote? Horizontal asymptote using go to this direction. Oh, this graph getting close to this line. That's the y equals 0. Same thing is the left side. Go to this direction, getting close to this line. Horizontal line, y equals 0. That's you're going to find it. Last one, guys. Number 3, vertical asymptote. Can you find it? Can you notice it from the graph? Something is not connected to the graph. That's going to be vertical asymptote. But here is all continuous. No vertical asymptote. How about horizontal asymptote? Going to this direction, function is getting close the horizontal line, this one, y equal 4. So y equal 4. Going to the left side, graph is getting close the horizontal line. That's the y equal 4. That's you're going to find the vertical horizontal asymptote line from the graph. Next one is how going to find the vertical horizontal asymptote line from the function when they given. Guys, look at this one. So we not sketch the graph yet, but look at this one. They give the function. How can find the vertical asymptote line? Here is a rule, guys. First vertical asymptote, if you remember correctly, previous old slide or find the domain, vertical asymptote related to this denominator. Vertical asymptote, how can find the denominator 0? X equals 3. That's the vertical asymptote. So domain is you remove the x equals 3, but that's gonna be vertical asymptote. Horizontal asymptote is a little tricky, guys. Horizontal asymptote, when you're talking about horizontal asymptote, check the degree. What is the degree of x minus 3? That's gonna be 1. So I'm gonna put degree is 1. How about degree constant? Constant, we say degree 0. Degree is 0. Which one is 0? Bigger, guys. Which one is? Denominate is gonna be, denominate function is bigger than numerate. Then horizontal asymptote is y equals 0. That's the theorem. Okay, let's go next one. Okay, vertical asymptote, you want to find denominator 0, right? So 3x squared plus 5x minus 2 equals 0. Can you factor it? You have factory, right? You're going to find the zeros right there. So you want to factor it. How can you find it? This one, guys. This moment, I'm pretty confident you guys can do all the factoring, right? 3x minus 1, x plus 2 equals 0, right? So you're going to rewrite this one if you want. This one is x minus 4, 3x minus 1, x plus 2. There is no common factor. So vertical asymptote line, you're going to find it. This one equals 0, this one is 0. So 3x minus 1 equals 0, x plus 2 equals 0. So x gonna be 1 over 3, x equal negative 2. That's the vertical asymptote. Horizontal asymptote, you check the degree of numerator denominator. What is degree of numerator right here? What is degree? That's the 1. What is the degree? Here is gonna be 2, degrees 2. So that case, horizontal asymptote is y equals 0. Okay? Now, you guys curious about what if the degree is same or degree of numerator bigger? I give the next example. This function f of x, 4x squared is x squared 4 vertical asymptote. Can you find this one is 0? X squared plus 4 equals 0. Can you find it? No. You can't find any x value. So no vertical asymptote. Let's go horizontal asymptote. We talk about degree. What is degree here? That's gonna be 2, degree 2. How about here? Degree 2. Same degree, then you're gonna check the coefficient. So y gonna be, what is coefficient? 4 over what is coefficient? 1. That's you're gonna find y equal 4. 1 is the 4. That's how I'm going to find it. Let's do one more example about the horizontal asymptote. So let's have the f of x, guys. X squared x plus 1. Okay, let's find the horizontal asymptote. Horizontal asymptote gonna be, what is degree here? Degree is 2. Here is degree gonna be 1. Which one is bigger? Numerator bigger, then no horizontal asymptote. That's the how to find vertical and horizontal asymptote. Let's everything is put together and sketch the rational function, guys. I give the direction how to sketch it, guys. Let's do one by one together right here, guys. So what do you have to do? First, x-intercept, y-intercept. How can you find the x-intercept? This one first, guys. And when you find the x-intercept, you plug in x equals 0, right? So this one gonna be f of 0. Oh no, sorry, that's the y-intercept, right? I'm sorry, guys. Y equals 0. So this one is 0 equal x plus 3, x minus 2. So you times x minus 2 both sides. Left is 0 times x minus 2 is 0. Right side is x plus 3. So x equal negative 3. So y-intercept is negative 3 and 0. Okay? Now, let's do the y-intercept. Y-intercept, this time x equals 0. So f of 0, you have 0 plus 3, 0 minus 2. That's the negative 3 over 2. So y-intercept gonna be 0 and negative 3 over 2. You find it. Next one is vertical horizontal asymptote. Vertical horizontal asymptote, right? Vertical asymptote is denominator 0. Let's do vertical asymptote first. X minus 2 equals 0. X equal 2. That's the vertical asymptote. How about horizontal asymptote? Gonna be check the degree. Here, this degree is 1, this degree is 1, so y equal coefficient is 1, coefficient is 1. That's the horizontal asymptote. So you finished two things. Now, additional point, you can wait a little bit, guys. Now, we're gonna sketch it. How gonna sketch it, guys? First, you're gonna plot the x-intercept, y-intercept. So x-intercept is, you say, negative 3 and 0. Y-intercept gonna be, you say, what? We find the negative 3 over 2. Okay? You find it. Now, you're gonna sketch the vertical horizontal asymptote. X equal to, let's do the dot. That's the line, horizontal, vertical line. Here is a y equal 1. That's the line. This one, vertical horizontal line sketch, you guys remember that. So then this one is connected because that's the point. Then you plug in the any number right here. You're gonna plug in the any number, figure it out. What are you gonna find this? So that's the additional point gonna be. So x equal negative 4, f negative 4. You calculate negative 4 plus 3, negative 4, negative 2, negative 1 over negative 6. That's the 1 over 6. So that's gonna be right here. This one is horizontal asymptote right there, right? Vertical asymptote right there. Okay, that's you sketch it. How about the other side? Here is a 2. Bigger than 2, you're going to pick any number. So I'm going to pick x equals 4. F over 4, guys. So 4 over 3, 4 minus 2, 7 over 2. So 4 is 7 over 2, 3.5, right around here. That's the vertical. Here is a horizontal. So you're going to sketch this direction. Have to make sense? This one, can you see that? Another one. Can you find the domain? Domain gonna be, you are not included to negative infinity and to n infinity. Range gonna be negative infinity and to n infinity. All right. This is practice question, guys. Sketch the rational function. I give all the direction. Guys, just thinking about find x-intercept, y-intercept, vertical, horizontal, asymptote, additional point, sketch the graph, pause the video. You try it by yourself. Let's do the x-intercept first. X-intercept gonna be y equals 0. Y equals 0. 0 equal 4x, x squared minus 4. This gonna be x equals 0. So x-intercept 0 and 0. That's you find the first. Y-intercept you plug in the x equals 0. F of 0, that's gonna be 0, negative 4 is 0. X-intercept 0 and 0. Let's do vertical asymptote. Vertical asymptote, how can find the denominator 0, right? X squared minus 4 equals 0. X squared equals 4. Very careful. X is positive negative 2. So you have two vertical asymptote. X equals 2, X equals negative 2. How about horizontal asymptote? Horizontal asymptote, check the degree. Degree gonna be what? Here is degree is 1. Degree is 1. Here is degree is gonna be 2. Which one is bigger, guys? Denominator is bigger than y equals 0. That's the horizontal asymptote. Let's hold the additional point. Let's sketch it right here. So what do you see? You say vertical asymptote is negative 2. 2. Here is a y-intercept, x-intercept 0 and 0. So horizontal asymptote right here. So you're gonna pick additional point, couple of additional point right there. X equals 3 first. X equals 3. F of 3 gonna be, what is the function? It's very hard to see, right, guys? Here is 12. 3 squared minus 4. So 12 over 5. That's the x equals 3. So here is a 12 over 5. Here is right there. So you're gonna sketch this one. Right? So here between the negative 2 and 2, so I'm gonna pick x equal 1. So f of 1, 4, 1 square minus 4. 4 over negative 3. That you find it. So here is 1, negative 4 over 3. Here is right there. Then negative 1, x equal negative 1. F of negative 1, negative 4. Negative 1 square minus 4, that's gonna be negative 4 and negative 3, 4 and 3. Here it is right there. So I'm gonna sketch it. This vertical horizontal asymptote. One more point, bigger than negative, less than negative 2. So I'm gonna pick x equal negative 3, f of negative 3. Negative 12, negative 3 square minus 4, negative 12, 5. So negative 12 over 5, so around here. So you're gonna see this direction. Able to make sense? That's how to sketch it. So extra question is, what is domain? Can you see the domain? Domain is, we talk about denominator cannot be 0. That's why you find x equal negative 2, x equal 2, that's denominator 0. Another way you're going to domain negative infinity and negative 2. Negative 2 and 2. 2 and infinity. That's the domain of this function.